Definition section. See, in the when you write a C program, there is a structure to follow, right? First comes the preprocessor directives, and then global declaration, right? Or you can say first you will start with comments and then preprocessor directives and then global declaration and then header files and then main function and then variable declaration, right? There is a different section you have to write when you write a C program. In the same way here, while writing Lex program, you have to follow these three sections: definition followed by rules followed by user code. Okay. In definition section, what are the things you can include? See, you can write at the definition section the header files, like see, it's similar to C language code. Okay, not exactly C language, similar. Okay, so the first definition section may include header files. Like if I need a few input output files, then I will include stdio.h file. Okay, and if I need any other libraries, then I will use stdlib.h. So those header files you can write it at the definition section, and you can declare the variables. Okay, if you need variables in your Lex program, that you can declare in the definition section. Okay, and also you can perform initialization also, with or without initialization. Fine. And if you need to write any functions, that also can be included in definition section. So usually definition section includes either header files or variables. You can initialize with values or without initialization also do. It completely depends on the program that you are going to write. Okay, and also C functions can be written. This is all about definition section. Okay, next we'll see a small example for definition section. Just see here this part. This is definition section, and do remember, while writing definition section, it has to start from percentage followed by left curly brace. Okay, percentage followed by left curly brace. Okay, and then in the next line you can write what are the things that you want to include here. Either it may be header file, variables, functions, anything. Okay, and this definition section has to terminate with percentage d followed by right curly brace. Okay, this is the what syntax you need to follow. The first thing is what? You have to start the definition section by writing percentage followed by left curly brace. In the next line, include the required uh, things here like header files, variables, and all that, and close it with uh, in the first line only. Okay, percentage followed by right curly brace. This is how you're going to write the definition section. Okay, so any doubts here? Do you understand this?
Yes.
Yes. Okay, we'll move to the second section of the Lex program, that is rule section. Okay, see here, rule section consists of series of rules. Okay, that's why the name given as rules. Okay, so rules should start with percentage, double percentage symbol. Okay, within which you are going to write the regular expression, or you can call it as pattern. Okay, and after that leave one space, and it has to followed by action. So whenever you write this regular expression, what is the action to be taken? So that you are going to write it in the action section. Okay, action part. Do remember, at the left side you are going to write the regular expression. Okay, once you complete writing the regular expression, leave one space. Okay, and then write action part. Okay, action part represents what actually this regular expression, I mean, whenever this regular expression is encountered, what action it has to taken, or what action need to be taken, that you are going to mention under action part. Now, what is regular expression? You have studied regular expression or pattern in AT and C, right? So what is regular expression? Yes? Anyone? No one? Anyway, see, this regular expression is a sequence of characters, okay, that specifies a search pattern. So that we call it as regular expression. Fine. We'll see a few examples in the next slide, then you will understand it better. Okay. See, based on the requirement, you have to write the regular expression and what action need to be taken. That should be written at the right part. Okay. So do remember, when you write the regular expression, after completing writing this, you have to leave one space and then it has to followed by action. Fine. So, and it has to terminate with double percentage. Fine. That is all about rules section in Lex file. So consider this example. Okay. So this is a regular expression. So what does this represent? It is a regular expression, or you can see it is a pattern. Okay, where it represents lowercase alphabets from A to Z followed by capital A to capital Z. Okay, this is the regular expression. If in your input, okay, have written an expression like in the last example, like A is equal to B plus C into D, right? So where A, B, C and all other identifiers, right? So you can match that input with this regular expression because it lies here, right? It matches with this character class, or it matches with this pattern because those identifiers or the alphabets, what I said, lies here, right? When it matches with the given, if the given input matches with this regular expression, then you have to take certain action, that is printf. It is an identifier. I'm going to print on the output screen saying that it is an identifier. Okay. So see, I'll write a program I want to read alphabets from the keyboard. Okay. So if I press A, it has to print it as it is an identifier. Okay. So you have to match the given input with this regular expression. If it matches, A lies in this pattern, right? Because if you write the small a or capital A, whatever, it lies here. So if it matches with the given pattern, so then what action you have to take? If it matches, you have to print it as it is an identifier. This is how the rule section works. Okay. Next, a simple example have considered where I am going to count the number of lines in the given program and characters that are present in the program. Okay. Now consider I have written a C program which has header file, void main, okay, and then a two statement like printf hello svit and another printf as hello world. Okay, so consider this is a C program. Then for this program, when I give it to the compiler to compile, the first phase is that lexical analyzer, right? So when the program is given as input for LA at the scanner, so first I have to write Lex program, right? To find out the tokens for this input, I have to write a Lex program. So this is how you're going to write Lex program for the given input. What is the input? I have written a simple C program where a few printf statements are written. Okay, so here, what is the first section? First section is definition section, isn't it? So in definition section, you can write the variables that you require, right? So here I have written number of lines and number of characters of data type int. Okay, so and I'm also initializing it to 0. Okay, both the variables I'm initializing it to 0. Here you can declare the header file has hash include. I'm not able to write here. Just remember, you can include header files as well. Okay, first I'll declare the required variables, because according to the program I have to find out how many lines are there in the program and how many characters are there in the program. Okay, so this is the content you are supposed to write it in definition section. And do remember, it starts with percentage followed by curly brace. Okay, and then write the required data here and close it with percentage followed by curly brace. This is all about definition section. And this definition section has to followed by rules section. How it starts? It starts with this delimiter, percentage followed by percentage. Okay, in the next line you have to write the regular expression, or I can say pattern. So what you have to find out? You have to find out number of lines, right? So that can be you can find out using new line character. So that's why I have written regular expression for this as what? Slash followed by n, which represents new line, right? So when this is encountered, or when the given input matches with slash n, then I'm going to count the number of lines. Okay, this is the action I'm taking. Okay, and then I'm using one more pattern here, or regular expression, that is dot. Okay, see this dot says, apart from this, which regular expression I have written? Slash n, right? Apart from this, whatever content that you have written in the C program, that will be matched with this dot operator. Do remember? See, regular expression, the first one I have used here, slash n, which represents to increment or to find the number of lines, right? I need to find out number of characters as well in the C program. For that, I'm writing the expression, regular expression as dot. Here in the Lex program, if I write a dot as a regular expression, it says excluding this slash n, whatever other characters that are present in the program, that will be matched with this dot. Okay, other characters means you can keep a count of it, right? You're going to increment and store it in number of characters. Okay, when this is encountered, it will take this action. When slash n is this pattern is matched, then number of lines will be incremented, or it will count the lines. Okay, so this happens till it scans the complete code of the program. Fine. Is it clear to everyone how to write the definition section and the rules section? I will explain how to write this regular expression in further slides. But do you understand the syntax to be written by considering this example? Do you have any doubts? Are you all following this?
Yes, ma'am.
Any doubts? Any doubts?
No, ma'am.
No? Okay, then I'll continue with the next part. Okay, so here comes the last section of Lex program, that is user code or C code. Okay, here we are going to write the C program. So we will start with the main function, main, followed by parenthesis and the left curly brace, and I'm going to call a function here, that is yylex. Okay, so this is a function which is used to, when this function is called, the control will go to this part. Okay, and it'll check the patterns here, written patterns here, and it'll find out the what is the action that are taken here. Okay, what actions here written. So it will count the number of lines and number of characters, right? So the values are stored in this variables, right? So YYLX function is called. When this function is called, this will go to the rule section. It will check the regular expression, and it will also check the action that has to be taken for this regular expression. What action we have taken here? We have counted the number of lines and characters, right? So that you're going to print it up with the help of printf statement, that is number of lines and number of characters with the help of printf statement. Okay, so this is how you're going to write the user code. Do remember, user code starts with main function. In the main function, you have to call this yylex function. Okay, when you write this yylex function, then only the control will go to the regular expression, and it will see what are the action it has to taken when the pattern is matched. When it is matched, okay, and it will note the action that has to be taken, and at last you have to print the number of lines and the characters, right? So that's why you're going to print it up with the help of printf statement. Okay, this is all about a simple example for Lex program. Fine, this is how you need to write user code. That is about the three section of Lex. One is definition, then next one is rule section, and the last one is user code. Fine. So next we'll see the regular expression. See, I say regular expression, right? So here I can write the regular expression as AB within the box bracket. Okay, that you can call it as character class. So it says either it can match A or it can match B. Okay, so see, if I'll write a C program where I will be reading A and B. Okay, so when I read the value A and B, what happens? It will check in the rules section for this regular expression. Is it matching A? Yes, it is there. Okay, then whatever action that you are writing for this regular expression, that will be taken care. Okay, you may say it as an identifier, or you may say it is an alphabet. That depends on the action that you're going to write for this regular expression. Okay, but if you write a regular expression like this, then it matches either A or it matches either B. Okay, you can also write the character class or the regular expression as A to Z. It says either it can match A or B or C till Z. Okay, this hyphen represents the range. Okay, and next I can write the regular expression as numbers, or you can see alphabets. Sorry, or you can also say negative numbers, or you can say positive numbers, right? So in that case, you have to write the regular expression like this, like minus or plus 0 to 9. That means all the digits which is not a letter. Okay, next you can also write a character class or a regular expression like this: negate A to Z followed by A to Z, which says any character which is not a letter. Which say, see this negate is there, right? It says it can match with any character, but not with the alphabets. Either it may be the lowercase or it may be uppercase. Okay, so and then this I said already, dot, right? It matches with almost all the character. Fine, except new line. Except new line, it matches with all the characters that you write it in the program. Okay, And next, few other regular expression, you can write it as r followed by star, which means what? 0 or more r, right? So r plus means 1 or more r. R followed by question mark, 0 or 1 r, right? That is an optional r. So if you write r followed by 2 comma 5, then what it says? Anywhere from 2 to 5 hours. So that anywhere 2 to 5, the number of times r can be repeated, right? So 2 comma, if I write like this, then 2 or more hours. If I write like this, then exactly 4 times r. So anyways, you are well versed with writing regular expression, right? In AT and C, you might have written many more regular expressions, right? So few examples I have given here, and the same you have to follow while writing the code. Fine. And I already told you this hyphen represents the range. Okay, either it from capital A to capital Z or small a to small z, like that. It represents the range. And then this operator slash, we call it as look ahead operator. Okay, so it says matches the preceding pattern only if followed by the succeeding expression. Let's consider this example. What I've written, A immediately followed by 0. I've used look ahead operator followed by 1. So what it says, if you use this as a regular expression, this matches with A immediately followed by 0 only if A01 is the input string. Okay, so we will be using look ahead operator in the program, in the first program of your syllabus. So do remember, it matches with A0 only if A01 is the input string. Fine. So these are the few regular expression, and a few more is given here. This I already explained. One more here, A or B. Even in this way also you can write it. Fine. Next, see, that is with respect to regular expression. When it comes to Lex program, you need to understand few variables that we will be using in the Lex program. So few of it I have listed here. Here first is Lex, YY Lex. So this function, so this is what it invokes the Lexer. Okay, so I already explained, you have to write YYLex function in the user code part, right? User code section. So when you use this YYLex function, it invokes the Lexer and it returns the token. See, where YYLex in turn it calls the regular expression and it will look into the action that need to be taken. Okay, and then it finally returns the token. Okay, another variable is YY text. See, this is pointer to matched string. Okay, so for the given input, the input is checked with regular expression, right? So if the given input matches with the regular expression, then for the matched string, you need a pointer to point out. So that we call it as YY text. Okay, and then YY length is length of the matched string. YYL val is value associated with the token. See, when the token is generated, a value will be associated with the token that is represented with YYL val. Okay, YYL val. And next, YY wrap. This is used to wrap up. Returns 1 if it is done and 0 if it is not done. Okay, we'll see this function in the program, then you will understand, because I need a good example to explain this YY wrap function. When I take up the program, I'll explain that this YY wrap function in detail. Fine. So here we use a file pointer here, that is YY_out, which means it is a pointer to the output file. By default, output file here it is monitor. Okay, and another file pointer is YY_in, which represents input file, which says by default the input file input pointer will be the keyboard. Okay, this pointer, see YY out, this always points to the monitor, and YY in, this always points to the keyboard. Okay, and initial, this to start the condition, begin to condition, switch starts the condition, this echo, and write match string. So this echo and all, we will see it in the program in detail. Okay, so these are the few variables you have to remember: YYLex, YYText, YYLVal, YYWrap, YYOut, YYIn, echo. So these are few important variables you have to remember. Okay. The last thing, see, I said we are going to write the code in Fedora or Ubuntu platform, right? So the extension, you have to execute this file, right? So these are the commands you have to follow for the same. First, you have to save the file in the extension .l. Okay, then compile this Lex program with the help of command Lex. Okay, so when you compile Lex program, the output of this file will be C program, that is lex.yy.c. Okay, since it is a C code, again you have to compile this C code. How do you compile? Using C compiler, cc followed by lex.yy.c. Okay, once you compile this C code, you will get a output file that you're going to execute by following this command, that is ./a.out. So these are the 4 steps you have to remember to execute Lex file. First, save the file in the extension of .l, and then compile this Lex file with the command Lex. When you compile the file with Lex command, it will give you the C code. Okay, that we call it as lex.yy.c. Since it is a C program, again you have to compile with the C compiler using the command cc followed by lex.yy.c. Okay, when you compile this, it will give you the output file a.out. The output you can get it by executing the command ./a.out. So when you execute this code, the required output for the program will be generated on the output screen.